Okay. Hi, Rachel. This is going to be a test of writing things like this and doing them out. So I'm just going to show you how to do an integral, which you probably don't know at all what that even means, and that's okay. And this probably won't even make sense because I'm not going to explain it much. I just want to see if this works, this setup. I don't know. So this is u substitution. If we had the integral of, I don't know, 3x, hold on, I gotta think about this, because that's just integration by parts, which I can still do, but like, how do we not? Wait, what? Now I don't even get when you don't do it. If I did like e to the x, that's two separate things. So what you would do is this would actually be integration by parts. Oh god, it's weird to write this way. Okay, so what's the first thing? Well, if we do the silly little acronym, that's for inverse log algebra trig exponent. So that's kind of the order from, at least I'm literally not even explaining this, I'm literally just doing the math, which is just not really, I don't know. So in this case, algebra would come first, so it would be the u, so 3x, and this would be e to the x d of x. This would be am I supposed to take the derivative of that and the integral of that? I think that's how it works. So this would just be e to the x, and this would be 3 dx. Is that how it works? It's bad that I don't remember. Oh, damn. So this is indefinite, which means there's no numbers we're trying to get it to. This would be fun to explain, but I'm just hungry and so demotivated because I just have been doing really bad on my stuff lately, which is just making me obviously less like confident. So oh man, okay, I gotta be able to at least finish this, you know what I'm saying? I just have so many different math things running through my head. So if we're here, what we gotta do, the formula, uv minus the integral of v du. I forgot about that. Okay, so 3x times ex minus the integral of e to the x, 3 you pull that out, so it would be 3, right? And then you just have 3x e to the x minus, wow, almost like it's just 3. I think that's literally just it, because e is very interesting, because kind of like pi pi is just a constant. It's just a number. It's just 3.1415926, blah, 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 something like that, right? Well, e is actually the same kind of thing. When you see on your calculator, if you do something wrong, or not do something wrong, you do a calculation and it says like 1.25 e and then another number or something like that. It looks like, I always thought it was like error, but it's usually e to the something, and it's just another number, and that's a thing the calculator knows how to multiply by. So e is a constant for something. I forget what it represents exactly, but I know it's like 2.7 something forever or something like that. I forget how it comes into play, but it's some sort of constant that means something. Hold on, I gotta charge my computer. So yeah, I sorry, a lot going on here. I want to do this for you because if I can explain it to someone, then I know how to do it. That's what my teachers and Raghav have told me. So I want to be able to explain it. So I'm just explaining E right now, which is not really important for me. But one of the rules that's just kind of how it works is, without even explaining to you what an integral or a derivative is, which are the two main kind of things you do, just like multiplication or division or addition, like an operation like that. It's kind of just an operation that we do in calculus. And when you take the integral or the derivative, you usually end up getting like, either you take away the x or like it's a different number, like there's all these things. But when you do it of e, anything involving e is usually just the same thing. I honestly don't really remember exactly the proof for that or like why that is, but all I remember is just if you take in this case, the integral of e to the x, it's still just e to the x, and same with the derivative, it's just still e to the x. How the derivatives work, man, that's like a much longer lesson. It's hard to try and quickly explain it, but the rule for derivatives is this: if I have 3x, actually no, let's do this. Let's do 3x squared. Right? Can you see that? Okay. If you have 3x squared, and you want to take the derivative of that, there's a simple sort of formula thing where it's x n minus 1 times n. I'm pretty sure that's the derivative type formula. And what you do is the derivative of 3x squared. Well, if we follow this, you do the number in front times the number up top. So 3 times 2 is 6. That's a horrible 6. But it's 6x. And then you just minus 1, which would just be nothing. So it's 6x. If we do another one, if we do 5x to the 4th, if we follow the same thing, 4 times 5 is 20. Jeez. I'm writing all weird so you can see it properly. 20x minus 1 up here, 3. So it's 20 to the third. Now, that is the derivative. But the integral, which is a fancy way of saying this, is the integral is actually just the antiderivative. They use the name interchangeably, and it's in the name. It's just the opposite of the derivative, which in this case just means you're going backwards. So the integral of 20x to the third is 5x to the fourth. And the integral of 6x is just 3x to the second. Now the formula for that is the one that I almost wrote before. It's x n plus 1 over n plus 1. Or, yes, I think that's it. And you can see that that makes sense because what we do is, for this one, for example, the integral, we would say, okay, 6x, and then n plus 1. Well, n isn't there because n is technically 1, because anything to the first power is just itself. So it would be 1 plus 1 over, and then the same thing, 1 plus 1, which equals 6x2 over 2. And if you just do 6 divided by 2, you get 3x. So it equals the same thing. Same thing here if we do that. 20x 3 plus 1 over 3 plus 1. What do you know? Look at that. That's 20x to the fourth divided by 4, which in turn, if you divide 20 by 4, is 5x to the fourth, which is the same thing as up there. So that's like a very basic comparison between the derivative and antiderivative. I can try and go back into it. I don't know, how long is this video? 11 minutes? Okay. Yeah, I should probably just stop it here. This is just me doing random math stuff. But basically, we spent a lot of the first year of calculus, like calculus 1, going over, not this, just derivative stuff. And there's a lot more to it than just this. There's a lot of different ways to calculate it, going over just what it means, defining it, graphing it, stuff like that. Because the graph of the derivative is just like the slope. So if we have a graph here, and we had like a curve kind of like that on the graph, the derivative is essentially saying we're given a bunch of points. So like if they told us to find the derivative at 3, 2, right? 3, 2, if they said like find the derivative at 3, 2 or something like that on this graph, well, let's just say 3, 2 is right here, right? Derivative is the slope at that point. So literally derivative is just slope. But in this case, it's not the same slope as in like, it's just a straight line. It's that straight line if you put it onto this graph. So the derivative at this point would probably look something like that. That's the path it would follow, right? Something like that. So the derivative at this point would just be, if we said it was 3 over 2, it would probably be 2/3, I guess, right? Like that's pretty simple. But sometimes the graphs are like this, and the thing we're trying to do, is something like that. So it's like there's a lot more to it that you can try and figure out. And now this year, what we're doing, mainly, we barely went over integrals in the end of Calc 1. It's just a general idea. But now we're going into how we can utilize various different ways to find integrals. I just had a project that I can go over, actually. I might do that. That would be kind of fun. Talk about this project I had where it was a physics problem for calculus, and we were basically using the integral to solve the problem, because you can have something simple like it's just going in a straight line, and that's easy to solve. But in many real life situations, like I said on this page, many things, whether it's a car or the speed of something or literally anything, it's not just linear, it's pretty different, curvy. So we can use integrals and derivatives and such to find different things. The integral is interesting because the integral can actually tell us the area underneath the curve. So if we need to find the area of something, you can actually usually take the integral in a certain way, and that number you get is essentially the area underneath, like if we were finding the integral from 4 to 6 right here, we would get the area in between the origin line and the graph itself drawn. There's so much to it. I think I do want to actually go over it like this with you and probably still put it on YouTube. You don't have to watch, and maybe I won't even put it on YouTube, but I think it'd be good for me to explain this like this. Yeah. So I'll post this on YouTube. And I'll do one of that project. I don't even know if I did it right, but I think it'd still be interesting to talk about, because why not? God, I have so much to do this week. All right, let's see if this worked.